So load balancing in ether channel. Okay, by default load balancing algorithm is by default source MAC address. By default load balancing algorithm is source MAC address. Okay, and total number of load balancing algorithm that switch supports is depends on the hardware. It depends on the platform of switches. Done. Guys, if 8 links are in active state, if between switches, let's say I have two switch 1 and switch 2. Between switch 1 and switch 2, let's say there are 8 links active. There are maybe 16 links we have bundle, but 8 links are active link. 1, 2, 3, 4, 5, 6, 7, 8. Now you tell me, to represent 8 links, how many bits is required? To represent 8 links, how
3.
many bits? 3 bits is required? Definitely 3
Yes.
bits is required, right? So switches is going to use 3 bits for the load balancing. Let's say this is my switch 1, and this is nothing but switch 2. This port is port number, I'm saying 1 to this, 1, 2, 3, 4, 5, 6, 7, and 8. And here also we have these 8 links. Okay. Now to represent 8 links, only 3 bits is required. So switches is going to use 3 bits to perform load balancing. See how. Let's say here I have one computer, and here I have another computer, and here I have another computer. 3 computers are there. Okay. Let's say this computer 1 have MAC address 0A. This machine MAC address is 0A. This machine MAC address is 0B, and this machine MAC address is 0C. Any IP address this machine is using, let's say 10.1.1.1. This machine is using 10.1.1.2, and this machine is using 10.1.1.3. Okay. Now, and here I have one computer or one server. Let's say here I have one server, or this switch 1 is connected with one router, and through router this switch is connected with ISP. Let's say this is server. Very simple. Server. Done. This server IP address is, let's say 10.1.1.100. This server is located in same subnet, and MAC address of this server is, let's say 0A. Let's say MAC address is AA. MAC address of this server is AA. Now, when PC1 means 10.1.1.1 want to ping 10.1.1.100, source IP address will be 10.1.1.1, and destination IP will be 10.1.1.100, right? Source MAC will be 0A. And what will be the destination MAC, guys? Destination belongs to same subnet, so destination MAC will be the MAC address of destination AA. Yes or no? This is the traffic which this PC will generate. After that, this PC will forward this traffic to switch. This is the ICMP traffic. It will forward to switch. Switch will receive it on this interface. First of all, it will learn source MAC address on this interface. After that, it will forward the traffic to switch number 1. Yes. Now switch 1, switch 2 need to use one link. Out of these link, it will use any one link. Now it will decide I need to use which link in the bundling, because we have bundled the 8 links. So it will convert source MAC address, because by default algorithm is source MAC address. So it will convert source MAC address into binary. Switch 2 needs only 3 bits, because as you told me that to represent 8 links only 3 bits is required. So it will convert last value of source MAC address into binary. So binary of A will be what?
1010.
1010. And out of these 4 bits, it will use how many bits? 3 bits. So 3 bits
Last
means
3.
010. And after that, it will convert this binary into decimal. What value you will get?
2.
2. So it will use link number 3. Link number, it will use link 3. It will forward traffic from which link? Link number 3, port number 3. From this link, it will forward the traffic. Getting my point? When this PC, okay, switch 2 will receive, it will learn source MAC address, means MAC address of PC1 on this interface, 0/3 interface. After that, it will check destination MAC. Destination MAC is the MAC address of server. Switch 1 will forward the traffic to server. Am I right? When server will generate reply, source MAC will be AA and destination MAC will be 0A. Again, when switch will receive this frame, this ICMP echo reply, what switch will do? Switch will convert source MAC address into binary. Again, binary will be 1010. So it will use last 3 bits, that will be 010. Decimal value will be 2. It will use link number 3. It will forward the traffic from same link, from this link. Getting my point? What is the binary of B? When PC2 will ping to server, when this PC will ping to server, that time source will be 0B and destination will be again AA. Switch 1 will convert source into binary. So what will be the binary of B? Binary of B will be
1011.
right? It will use last 3 bits, means 011. After that, it will convert this value into decimal. What value you will get in decimal?
2.
2.
Sorry,
2
3.
or
3.
3?
3.
3. It will use which link?
4.
Link number 4. So it will forward the traffic from this port. Switch 1 will learn MAC address of PC2 on port number 4. After that, it will forward the traffic to server. Again, server will generate reply. In the reply, source MAC will be AA and destination MAC will be 0B. Switch 1 will do what? Switch 1 will receive this message and it will convert source into binary. Source is what? AA. So again, it is going to use which link? Link number 3. Yes or no? That means when server is forwarding traffic to PC1 or PC2, switch 1 or switch 2 is using same link. For the reply, switch 1 will always use link number 3. to forward traffic to PC1, to PC2, to PC3.
Sir, one question.
Yeah.
Actually, when we will bundle all these 8 ports,
Okay.
so on switch 1, so that will be a single port channel. Say for example, the port channel 1. Okay.
Okay.
Now, any communication from switch 2, that is PC 1, 2, 3. Okay, whenever they are sending traffic to the server, okay,
Okay.
it will be going via this port channel. So on switch 1's MAC address table, if we check, then all the MAC address will be learned on port 01, correct? Port channel,
Correct.
not on single interface, correct? The
Correct.
traffic is passing through single interfaces,
Correct.
but it will learn on port channel only, correct?
Correct.
So on one port channel will be having these three PCs MAC address.
Exactly.
Okay.
Okay, so have you understand load balancing, how it is performing load balancing? See, when PC3 will ping to server, source MAC will be 0C and destination MAC will be AA. What is the binary of C? What will be the binary of C? 1100.
Yes.
3, it will use 3 bits. That means 3 bits means 100. Decimal value will be what?
4.
4. So it will use link number 5. 4 plus 1. It will forward the traffic of PC3 from this port. But again, when reply will come, source switch 1 will receive the reply where source will be 0A, and 0 it will convert 0A in, sorry, AA. It will convert source into binary. It will use 3 bits, last 3 bits, and it will forward the traffic from link number 3, because binary will be 0 1 0, decimal value will be 2. It will use link number 3. It will forward the traffic from this port. So every time when server will forward the traffic to PCs, switch 1 will use link number 3. And for these user, whenever these user will forward the traffic to server, like for PC1, switch 2 will use link number 3. For PC2, switch 2 will use link number 4. And for PC3, switch 2 will link use number 5. Is it clear?
Yes.
So we are performing actually load balancing only for the traffic which PCs are generating for server, right? We are not performing load balancing for the traffic which server is generating for the user. If server will forward any traffic to user, right, switch 1 will forward traffic always from port number 3 only. Same thing will
Sir,
happen if, yes.
sir, if due to any reason, say for example, port, uh, the return port from the server,
Okay.
okay, if say for example it is shut down or due to some error it is shut, error disabled,
Okay.
then which port again it will select?
LACP port ID. Have you remember in last class we had discussed LACP port ID? Lower
Okay.
8 lower ports will become active. So if let's say one port will goes down, port number 4 will goes down. So port number 5 will become active. Or
Okay.
let's say here we have port number 9 also, link number 9 also, but 9 link, this link is in standby state. So this port will come in forwarding state. But port ID of that link will be 8, not 5 or
Okay.
4. Okay. Or let's say this switch 1 is connected with one router and this router is connected with internet. So whenever again we have same problem, that whenever traffic will come from outside from internet to inside network, switch 1 will not perform load balancing, because every time source MAC will be the MAC address of this interface, gateway interface MAC address, right? So in this scenario we need to change load balancing algorithm. So what will happen when I will change the load balancing algorithm? Let's say here I have set load balancing algorithm now, source and destination MAC address. Now load balancing algorithm is source and destination MAC address. If load balancing algorithm is source and destination MAC address, guys, in this scenario, see, if PC1 will ping to server, source MAC will be 0A and destination MAC will be AA. When switch 2 will receive this frame, right? It will receive this frame on this interface. It will first learn the MAC address. After that, it is going to convert both source as well as destination into binary. So source binary will be A binary will be 1010, and destination is again A. So 1010. It will use 3 bits. So let me delete 1 bits. This is the binary of source and this is the binary of destination. On this two binary, it will perform AND operation. And operation, and after AND operation it will find one value will be what? After AND operation, what will be the value over here? 0 1 is 0, 1 1 is 1, and 0 0 is again 0. Same. Decimal value will be 2. It will use link number 3, right? So this time, let's say server is forwarding traffic to PC number 2. Source MAC is AA and destination MAC is 0B. Source binary will be 1010 and destination binary will be 1011. It will use 3 bits because we have 8 links, right? After that, it will perform AND operation. So after AND operation, value will be 0 1 0. 2, it will use link number 3. When server will forward traffic to PC3, PCC, 0C MAC address. So source is A, 0, AA means again 0, 1, 0, and C MAC address is 1, 0, 0. It will perform AND operation. Value will be 0, 0, 0. It will use link number what? Decimal value 0. It will use link number 1. Getting my point? Is it clear to everyone?
Yes.
In the same way, it will perform load balancing for source IP and destination IP. Done. Hope it is clear. Now, if I have only, let's say, 4 link between switch 1 and switch 2. I have only 4 link between switch 1 and switch 2. 1, 2, 3, 4. Then to represent 4 link, how many bits is required?
2.
2. So it will use only 2 bits. If I have only 2 link between switch 1 and switch 2, then it will use only 1 bits of source MAC address or of both. Like this, it will perform load balancing. Is it clear, guys? Is it clear? Tell me.
Yes, sir.
To all. And you already know
Yes,
how
sir.
to perform, how to change load balancing algorithm. Yes or no? Okay. If I have 8 links, then load balancing ratio will be what? 1 ratio 1 ratio 1 ratio 1 ratio 1 ratio 1, 2, 2, 4, 5, 6, 7, 8. It will perform load balancing in this ratio, right? And if we have 7 link, if we have only 7 link, let's say link number 8 have goes down. Link number 8 is, let's say, down. Now how many link we have? 8 link. Then what will be the ratio? If there is 7 link only, then ratio will be 2 ratio 1 ratio 1, ratio 1, ratio 2, 4, 5, 6, 7. This will be the load balancing algorithm. 4, 7 links. Okay. In the same way, if we have only 5 links, 4, 5 links, load balancing algorithm will be what? 2 ratio 2 ratio 2 ratio 1. How many link we have? 2 ratio 2 ratio 1 ratio 1 ratio 1 ratio 1 for 5 links. Oh, for 5 links it will be not like this. If we have only 5 links, then ratio will be this one. 2 ratio 2 ratio 1. Done. Is it clear? Yes, guys. And if we have 4 link,
1:1:1:1.
yeah, 1 ratio 1 ratio 1 ratio 1. If we have 3 link, 2 ratio 1 ratio
1.
1.
No, no, sir. 2:1 only.
Sorry.
3.
And if we have 2 link, 1 ratio
1:1.
1. And if we have 1 link, then it will forward all traffic from single link. Clear? 1 minute, guys. Let me check rack and let me access the devices. Now we are going to understand layer 3 ether channel. So first of all, let me access the devices. Switch 1 and switch 2. And I am going to access routers as well. So let me access R1 and R2. I will connect R1 to switch 1 and R2 to switch 2. Let me design the topology. See here between switch 1 and switch 2 I have 2 link. This is my switch 1. This is my switch 2. Here I have 2 link. Zero slash 19 and this is 0 slash 20. Okay, and here I have router 1 R1. Here I have one more router, R2. This is basically PC, PC1 and PC2. Let's say this PC is member of VLAN 10, VLAN 10, and this user are in VLAN 20. VLAN 20. If both are in different VLAN, definitely both will use different IP address. So let's say IP address of router 1 is 10.1.1.1 and IP address of this router is 20.1.1.1. Okay. Okay. And how router 1 is going to ping router 2? Then both router need default gateway. Yes or no? Both router
Yes.
need default gateway. So let's say default gateway of this router is 10.1.1.100 and default gateway of this router is 20.1.1.100. Okay. Now guys, let me configure this scenario, and if it is not visible to you, so I can do one thing. Yes. Now topology as well as console, both is visible to you or not? Topology as well as console, both is
Yes.
visible. Now I am going to first down all interface f1/0/1 to 24 and say shutdown interface range, say shutdown. On switch number 2 also I am going to down all interfaces, interface range f1/0/1 to 24 and say shutdown, and I will up only few interfaces, like between the switch 1 and switch 2 we have two link, interface range f1/0/19 to 20, and one more interface which is connected with router 1, that is f1/0/1. I'm going to say no set to this interface. Done. On switch number 2 also, interface range f1/0/19 to 20 and f1/0/2 is the port which is connected with router 2. Say no shutdown. Done. After that, R1 f0/0 is connected with switch 1, so I am going to run no shut command on f10/1, say shutdown, and no shut on f0/0, no shut. And here I am going to configure IP address 10.1.1.1 255.255.255.0 and say no IP routing as well to disable routing, and IP default gateway is 10.1.1.100 255.255.255.0. Sorry, default gateway this one. Done. Then router 2 fast ethernet 0/1 is connected with switch number 2, so I am going to down 0/0 interface f0/1. Here I am going to say IP address 20.1.1.1 255.255.255.0 and then no IP routing, and IP default gateway 20.1.1.100. Now guys, if I want to make communication possible between router 1 and router 2, you tell me first of all how many method you know. I want that router 1 should able to communicate with router 2. We have two link between switch 1 and switch 2. Tell me. First of all, here we need to configure one SVI for VLAN 10 and on switch number 2 SVI for VLAN 20. Am I right? Right guys, here we have to configure one SVI interface VLAN 10, say no shut and IP address 10 dot 1 dot 1 dot 100
100.
255.255.255.0. Should I configure SVI for VLAN 20 here?
No.
Not required. So go to switch number 2 and here interface VLAN 20 no shut and IP address 20.1.1.100
100.
255.255.255.0. Now if from router number 1, if I will ping their default gateway, will ping work? If I
Yes,
will,
default gateway should work.
how it will work, brother? You have not defined router 1 in VLAN 10. First of all, on
Oh
switch
yes,
number 1, interface F1/0/1, switch port access VLAN 10, right? And on switch number 2, interface F1/0/0/2, switch port access VLAN 20. And here VLAN 10 is not there and switch number 1 VLAN 20 is not there. Let me create VLAN 10 here. And on switch number 1 I am going to create VLAN 20. By the way, it is not required now, but let me configure it. VLAN 20. Okay, now can router 1 ping their gateway? Will ping work? Ping is working. Router 1 is able to ping their gateway and router 2 ping 20.1.1.100. Router 2 is also able to ping their default gateway, right? Now how router 1 and router 2 is going to ping? Okay, if I will ping, let's say router 2 from router number 1 ping and 20.1.1.1, on which devices traffic will drop? What will happen when I will ping to this IP address? Router 1 will forward the traffic to switch to their default gateway, yes or no? Because
at
destination
switch
belongs
one
to
only.
different subnet.
At switch one only it will drop
Why switch 1 will drop it?
because it does not have any next
Route
hop.
available.
Yes, yes, no, no route.
Okay, so see, I am not able to see even routing table of this router. By default, routing is not enabled on switch. So I am going to run one command,
IP
IP
route.
routing. And on switch number 2 also I am going to run IP routing command. Now on switch number 1, if you will check routing table, so IP route. So there is one network, directly connected network. Route switch number 2 have also one directly connected network, so IP route 20 network. Now I want to exchange these network between switches. How I will exchange it? How can I exchange these prefixes?
By dynamic, any dynamic routing protocol, sir, or
Dynamic routing protocol. If I will configure dynamic routing protocol, then nothing will happen, right? How dynamic routing protocol never see will come up. Let's say here I am running EIGRP router, EIGRP AS number 10, and let's say network 0.0.0. On dot switch number 2 also I am running a router EIGRP 10 and network 0.0.0.0. EIGRP neighborship will not come up because both are sending their hello message from virtual interface.
virtual.
Debug IP EIGRP packets. EIGRP debug EIGRP IP EIGRP events. Yes, number let's say 10. It is not showing hello message. debug. I think on switch 1 command is missing. Debug eigrp IP eigrp yes number 10. Debug command is here missing on switch. Okay, we are not able to run, but it is sending hello message from their virtual interface, because it will enable eigrp on which interface? On virtual interface, on SVI interface, yes or no? From
Yes.
SVI interface it is sending hello message. So what is the option? Option is we can configure IP address on this link. Here on this link we can configure the IP address. Let's say here I am running 12.1, here I am running 12.2, right?
Okay.
So let me try, let me see what will happen if I will configure IP on 0/19. I'm going to say no switch port first, and then IP address, let's say 12.1.1.1 255.255.255.0. Now if you will check routing table of this switch, so IP route, there is two network, 12 as well as 10, and router eigrp is number 10, no auto summary as well. Now I am going to configure IP on 0/19 f1/0/19, say no switch port, and IP address 12.1.1.2 255.255.255.0, and router eigrp is number 10, and say no auto summary. Now you can see eigrp neighborship is up, right? And now if you will check routing table, so IP route, so you can see this switch have learned this network 10.1.1.0 through eigrp. Next hop is 12.1.1.1. In the same way, switch 1 will have one route through eigrp, one network through eigrp, that is 20.1.1.1, right? And now router 1 can ping to router 2 also. You can see ping is also working, but we don't have redundancy between switch 1 and switch 2, yes or no? We don't have backup link between switch 1 and switch 2, yes or no? So I need
Yes.
backup link. So what I am going to do, I am going to configure one IP on port number 20 also, interface f1/0/20, say no switch port, and here also I am going to say IP address. Let's say here I am using IP address 21.1.1.1 255.255.255.0, and then on switch number 2, interface f1/0/20, and say IP address, first of all no switch port, no switch port, and IP address is 21.1.1.2 255.255.255.0. Now here also eigrp neighborship will come up. You can see the log message. Now there are two eigrp neighborship of switch, two eigrp neighborship between switch 1 and switch 2. So IP eigrp neighbor, two neighbor are there, 12.1.1.2 and 21.1.2. How many hello message it will generate? 2. How many hello message it will encapsulate? 2. How many hello message it will decapsulate? 2. How many update message it will send? 2, for both neighbor, right? So now I have redundancy, but let's say we have 8 link between switch 1 and switch 2, 8 link. So if you will configure IP address on every link, then CPU utilization of devices will goes high. CPU utilization will increase automatically, because it will encapsulate 8 hello message after every 5 seconds. Now it is encapsulating 2 hello message. So guys, better solution is, this is not the solution. Better solution is we should bundle these two links together, and you should run eigrp on that port channel. We should run EIGRP on that port channel. In real time, we are not configuring IP address directly on the physical port. So I am going to remove the IP configuration from physical port. Okay, interface F1/0/19. Say no IP address. After that, interface F1/0/20 and no IP address. Done. We have removed the IP configuration. Here GRP neighborship is goes down. Now interface F1/0/19 no IP address, and interface F1/0/20 and say no IP address. Interface F1/0/20 and no IP address. Done. So IP route. Now only directly connected network is there again. But this time between switches, the link is layer 3 link. So IP route. Layer 3 link, not layer 2 link. Because we have run what? No switch port command. So this time we are going to bundle layer 3 port. So this is called layer 3 ether channel. And how to do that? Again, configuration will be same. Interface range F1/0/90 to 20, and then channel group, then group number, let's say 10, and mode. Let me use active here, and on switch number 2, interface range F1/0/19 to 20, and channel group number, let's say 10, and mode here I am going to use is, let's say, passive. Active, passive, right? So ether channel summary. So wait for some time. Switch number 1. So ether channel summary. Okay, so here ether channel, wait. Which protocol we are using? LACP, because we are using mode active and passive. Active passive is for LACP protocol. So IP interface P10. Line protocol is up, and status is also up. So ether channel and let's say protocol port channel number of port is 2, that is fine. Protocol is LACP. How to check ether channel state? So ether channel only. This is L3 ether channel, not L2 ether channel. Group state is
Three.
L3. So interface port channel 10 and switch port. Switch port is disable. So run include fast ethernet and fast ethernet port is 10, sorry, fast ethernet 1/0/19 we are not able to see. Include port 10. Okay, leave. So ether channel summary. Now you can see ether channel is working fine between switch 1 and switch 2. And this time, so IP interface brief. We have one port, that is P10, port channel 10. This time we are going to configure IP address 12.1.1.1 on this port. Interface F, sorry, not F, P10. And I am going to say IP address 12.1.1.1, 255.255.255.0. Will a gRp neighborship come up? What do you guys think? Interface P10 and IP address is 12.1.1.2, 255.255.255.0. Now a gRp neighborship will come up, you can see, right? And now again router 1 can ping to this IP address. Ping is working, and if one link will goes down, let's say interface F1/0/19, say shutdown, ping is still working fine. Yes. So now we have redundancy as well. It will generate only one hello message. Switch 1 will generate only one hello message because there is only one neighbor. So this is the actual way how we configure inter VLAN routing with the help of ether channel. Between switches, how we configure routing protocol when we have more than one link. Any doubt, any question? No? Again I am going to up 0/19 port. So now guys, switching is completed. Now I think we don't have any topic in switching module. So next thing is we are going to discuss edge technology. Interface F1/0/19 and say no set. Neighborship is fine. Clear to all? FAM, VPN. NAT is a technology which is used to make communication possible between private and public network. Between private and public network. Let's say here I have one private network. This is my switch and I have some computer here, and this switch is connected with one router, and through this router I have connected to internet. This is ISP, and here is one server of, let's say, Google, let's say 8.8.8.8. So if these user want to ping 8.8.8 or want to access this server, because by default these user cannot access 8.8.8. The reason is very simple. The reason is that here this is public network and this is private network. So by default private to public communication is not possible. So that's why here we need to configure NATing. You know why it will not ping? Let's say here this user is using one IP address. Here let's say IP address is 1.1, here IP address is 1.2, here is 8.8.8, and this user IP address is 10.1.1.1. Okay, their default gateway IP address is 10.1.1. Let's say 100. Okay, MAC address of this machine is 0A and MAC address of gateway is, let's say, 0C. When this PC want to ping 8.8.8, it will generate ICMP traffic where source will be 10.1.1.1 and destination will be 8.8.8.8. Source MAC will be the MAC address of this PC 0A and destination MAC will be the MAC address of gateway, that is 0C. After that, this PC will forward this traffic to their gateway. Now their gateway will check what? Destination IP. Destination IP is what? 8.8.8.8. And guys, like 8.8.8, there are million of sites on internet. So is it possible to configure million of sites, routing for million of sites on this router? No. So here we will configure one default route 0.0.0.0 towards ISP. So it will check destination is 8.8.8 and there is no any specific route available in the routing table for 8.8.8, but there is one default route towards ISP. It will forward the traffic towards ISP up by changing the layer 2 information. When ISP will receive the traffic, source is 10.1.1.1 and destination is 8.8.8.8. ISP will forward the traffic to this server and this server will generate what? Reply. In the reply, source will be 8.8.8.8 and destination will be 10.1.1.1 and there will be no any route available for 10.1.1.1 on the public network. So ISP router will drop the traffic because ISP router will not have the information of private network, because like this computer there are million of users using same private IP address. There are million of user who is using same private IP address. So ISP never know you with your private IP address. ISP know you with your public IP address, with this IP address. With the help of single public IP address, ISP know the entire organization. Getting my point? And by the way, here on the ISP interface, there will be one access control list that will be denying all private IP address. So whenever request will come with private IP address over here, it will drop the request. So actually what we need translation on this router, on edge router. Here what I want, that whenever this router need to forward traffic to internet, to outside, before forwarding the traffic it should translate it. Let me show you how. Here IP address is 1.2. Now if on router number 1, whenever router 1 will receive traffic from the LAN user, right, if it will translate the source address to this public IP address, if it will maintain one table, and in that table if it will maintain that I have translated 10.1.1.1 into 1.1, right, and then it will forward the traffic to ISP. Now ISP will receive request with what source? 1.1, and 1.1 is reachable from ISP, so it can generate the reply. So it will forward the reply to this router, and again this router will translate the public IP address into this private IP address, and after that it will forward to LAN user. So this type of translation is done with the help of netting. Because on your edge router a technology is running that is called NAT, and because of that you are able to access internet. How to check public IP address? Let's say I need to check what is the public IP address of my device. So I can use one website also. What is my IP address? This website. You can see IPv6 public address, and it is calculating IPv4 address also. My ISP is Airtel Bharti and city is Mumbai, Maharashtra, country India. Okay, and you can see the public IP address. This is my public IP address. And when I am running command cmd ip config This is my private IP address. This is my private IP address. This is the IP address of my machine. Another way to check IP address is in network adapter setting. Also you can check your IP address. So through my public IP address actually I am able to access internet. Whatever traffic I am forwarding to internet, right, from my laptop will generate traffic with private source IP address. In source IP address will be the private, but on my router is going to translate the private IP address into this public IP address. Okay guys. Okay, so let me design one diagram over here. Here I have one switch. This switch is connected with some computers, and this switch is connected with one router, and my router is connected with internet. Okay, and on internet, let's say there is one loopback that is 8.8.8.8. This is my router, this is my switch. The IP address which I will use in this domain, the IP address which we are using in this domain is public IP address, and the IP address which I will use in this domain is private IP address. Here we will have private IP address, private IP address, or we can say this is my private network, private network, and this is public network. Public network. So in private network we will use private IP address, we will use private IP address, and in public network we will use public IP address. We will use public IP address. Done. Okay, so we have divided this network into two parts, private and public. Private and public. And guys, private network is called inside zone. In netting we have divide the network into zone, inside zone and outside zone. So this is private network is your inside zone, and public network this is your outside zone. For you this is outside zone. Okay, so let's say this is my fast ethernet 0/0, and this is my fast ethernet or serial 2/0. So serial 2/0 is outside interface, and fast ethernet 0/0 is inside interface. This is F0/0. To configure NAT, first of all you have to define inside and outside interface. So the interface which is connected to private network is called inside network, inside interface, and the interface which is connected to public network is called outside interface. So here on fast ethernet 0/0 you will run command ipnet inside, and on serial 2/0 you will run command ipnet outside. And after that there are multiple types of NAT. There are multiple types of NAT. This is your private network, like, right? In your private network there is one server, let's say there is one server, this server, and you know what you want to give access to this server to outside user. Let's say IP address of this server is 10.1.1.1, and you want to give access to this server to outside user. Outside means which is not connected to your private network, which is connected through public network. Maybe those user are also connected with private network, and through internet they are able to use internet. You want to access this, the access of this server, you want to give access to this server to outside user. Let's say outside user means there is one private network. Here is one company. In that company, let's say there are some employee, or this is company of branch offices of your company. Okay, here there are some employee. So this is also again private network, and this private network is connected through internet. Internet, and this time you want to give access to your server to these user. You want to give access of your server to these user. So this is what private to private communication. Yes or no? This is what private to private communication. Or guys, like this is a network of Google have also a private network, right? They have connected their network to internet, and they have given access to us, to their server. Yes or no? So you can say this is network of Google, and this is our network of a company, and we are able to access the server of Google. So that is also possible through NAT. Okay, is it clear? Any dot till here? Any dot to anybody till here? No. Now we have multiple types of netting. First of all, we have static net, static net. Then we have dynamic net, and then we have last one and the most popular that we are using is PAT, port address translation. Guys, nowadays we are not using dynamic net, we are using only a static net and PAT. You will use a static net whenever you want to give access to your server to, let's say, outside user, as I told you. Then you have to use a static net here. On this router you have to perform one-to-one translation, and is the PAT is the technology which we are using nowadays for the translation. Okay, so we will discuss all types of NAT and concept of NAT, right? One by one we will discuss all types of NAT, theory part plus practical part, but this is just an overview. If anyone have any confusion, anything, any question, guys, in this, then please let me know that why we are using NAT, and uh, means yes, why NAT is required. Is it clear?
Yes, sir.
That okay. Then I think it will be better if we will start NAT tomorrow from the beginning.
Sir, just one query. Like
Yeah.
on internet, they are showing many types of net translation. That is 6446, then 66. Sir, actually, total how many types of nets are available?
Three types of nets are there only:
Okay.
static, dynamic, and PAT.
No, sir. This is regarding the net type regarding this routing and switching. I'm asking that some concepts are there like net 64. So that is IP6 over IP4, I guess. So
Okay.
So, oh, like that is also one kind of net. So, total, how many types of net are there actually?
Mm, okay, I
Because
have to check it.
say in certain scenarios, I just don't want to go in deep, but I am confused. Like there is one 64 net 64, then there is net 66, then
Net 64
yes, sir, net 64, then net 66.
like this.
Yes, sir, yes.
Okay.
So that first one is when we search for first one, they will tell that uh, say for example there is an IPv4 link.
IPv4.
Yes. So we the network is private network is say for example in IPv6 or one network is in IPv6 and we need to net it using IPv4. So that net 64 is used. Then they are telling that net 66 is used. IPv6 is only netted. Like here, we are doing that static net and pad. In that also we are currently doing net 44 only, no sir. IPv4 to
Yeah,
IPv4. So
exactly.
so how many kinds of net is available actually?
Okay, okay. Don't worry. I will check it and let you. I will let you know.
Because sir, actually in as you already know, sir, in then here this is basically for regarding this routing, correct?
Correct.
But this, I guess, this net 64 then net 66 is basically mainly used in service provider network, I guess, or else where firewall are implemented. But in firewall also, sir, I have never noticed this kind of netting. They are only destination net or like standard net that only we use, correct? In firewall
Correct.
also.
Correct.
So
Correct.
actually, why this all net? I was confused. I was
I will
searching
check
on it.
it.
Okay, okay, sir. Okay.